give it a couple minutes, see who else is popping by. Probably gonna need some technical support because my code does not look shiny. Let's see. Alright, this looks doable. Cool. Alright. Just quickly gonna put out a tweet so that we know that we're live, and then we're cool. All right. So the last couple of I think days and weeks, I've been preparing the V1 launch for Event Sauce. The last year, for everybody was kind of hectic. For me, it's pretty much the same. And before this, I was really focused on getting Fly System 2.0 out the door. And now that this is done, I thought, well, now would be a good time to sort of divert my focus back to Event Sauce and really get that V1 out the door. With V1, what I also want to do is make sure that some of the parts that you can optionally use are a little bit nicer, are a little bit more stable, and a little bit more thought out. So one of the pieces that we had in V1 was the Doctrine Outbox message dispatcher. This was really Doctrine specific, so if you wanted to recreate this for example, Laravel with Illuminate database, for example, there was not really a lot of code that you could reuse, so I wanted to change that. Also got some new insights because we use this at work as well. So that's how I came about think like, hey, I want to get something new for the Outbox out, but I also want to take this opportunity to sort of go into what the Outbox is actually for, what kind of problem it solves, and how you need to think about it, so to speak. So before going into all that, for those who don't know me, my name is Frank. I made Event Sauce and Fly System. I work at Molly. We process payments in PHP, and yes, we're hiring. Part of the reason for me to have these kind of Outbox things at all is because we also need those things at Molly for reliable dispatching of events. And I'll show you in a minute what I mean with reliable. So today we'll be implementing the Outbox pattern. So we'll kind of need to know what this is and where it's coming from. The purpose of the Outbox pattern is to make dispatching events reliable. If you're operating at scale, and at Molly that's what we're doing, the amount of payments that we process is ever increasing, and with it is the increasing need of a reliable service. Otherwise, the people who we're processing payments for won't really be happy. And this extends also into to events. So we use events as a means to scale parts of our system or to kick off secondary processes. And we need those to be reliable. But if we're talking about reliable, you also need to know what do I mean when I say reliable? Or to flip this around and to say, like, if we need to make it reliable, what are the things that make it unreliable? Well, if you are looking at events, and events are often being dispatched from some sort of aggregate, so there's some sort of model that you're working with, operating with, and there's some internal mutations, and you want to save those to the database. But there are also a bunch of events associated with the action that you're taking. And most of the time, if you have somewhat reliable infrastructure, everything will be fine and dandy. So there's always this two-step thing. You don't want to use generally in database for queuing, so you use a queue and you use a database for storage. But this means that you have two network interactions, and from these two network interactions, one of each might fail. So for example, the first might fail, and this is, it's not a catastrophic scenario, of course, because what often happens is you want to store it in the database fails, there's some kind of database exception or persistence exception, and you don't even go into the second step, so there's no events to dispatch at all. What's somewhat more problematic, but still in some way, shape, or form still salvageable, is where you store something in the database, and this is your source of truth. So you want it to be accurate always. But then the sending of the events to the queue fails. This is not nice. For example, if we process a payment and the payment is actually paid on our end, but the event that we sent in order for the merchant to get a webhook to say that their payment was actually successful, and they don't receive this, this is not a nice experience. When I said this is somewhat salvageable, is when I talk about things that clients on the other end can implement in order to, distrust your ability to send out webhooks. You could simply say, it's like, if I receive nothing, I will just go and ask, right? With Molly being an API, and we always expose the latest status of your payment, this is not a problem. Though it becomes a problem when this is sort of an internal thing and you don't expect anything. So if you're kicking off a secondary process by sending an event to the queue, this can be problematic. Still, like we're in this half space where half of the stuff is salvageable and the other half is already problematic, but it gets worse. So you could also flip this around and say, well, I want to always make sure that I dispatch my events. So you do that first, and then you store it in the database. Again, if both work out fine, then nothing is wrong. And if sending the events to the queue fails, then again nothing is wrong, because storing in the database will just not happen. We say fine, but like ideally we always want to update the state in the database, right? So this is not always acceptable. So this is even less ideal than the other situation. But what can it be even worse is when the sending of the events goes right, and we actually do send the events to the queue. So we publish to the world like this has happened, and then our persistence fails. So in this case, we send out to our merchants that the payment was fulfilled, and then we send out a webhook saying, hey, this went all right. But what's actually going on is that the state in the database is still the previous state of that payment. So this is not great, because effectively your events are now lying, or sort of they're not really lying, but they're also not telling the truth about the current system, right? So to solve this, there is a pattern called the Outbox Pattern, and in this pattern, what you have effectively is a buffer table of events in your database. So for example, this is not a diagram I made, by the way. This is from, I think, microservices.com. They explain a bunch of these patterns, and I'll link to that in the comment later. But it kind of illustrates what's happening. So when we persist something in the database, so we persist our model, and this could be event source, but it could also not be event source, just a classic model. What we put next to it is a table that's just an append-only table that we fill with our events. And so when we insert these queries, we wrap this in an entire transaction. And what this transaction does is make sure that this fails or succeeds as one unit. So that means if us writing something to the database, storing our aggregate, if that succeeds, then also our events are dispatched. But this means that we now have a bunch of events in the database, and this is generally not what we want to use to dispatch events to the rest of the system, or rather, we don't want to use this as a means to consume it. So there needs to be a what they call a message relay. This relay is responsible for reading things out of the outbox and publishing that into whatever we want to consume it in. So this could be directly in a consumer. It's not ideal, but it works. But this could also be something of a queuing system. This makes sure that we don't have on dispatching these two network interactions, and then there's something behind the scenes that can reliably wait on these events and dispatch them to a queuing system. So the reason why this is important is you can, of course, if you have a two network interaction and one fails, you can retry. But what you can't really do is retry to infinity. Right? You still have this web request, and this web request is mostly is often capped to a couple of seconds, like 30 seconds, I think, is the PHP default for a request, or the Nginx default. And after that, it's closed. So you're not really sure what's going on there anymore. This could mean that either you just fail the entire request, or you just keep processing it but don't return a response, or your clients keep waiting indefinitely. It's not really a nice user experience put all together. So instead, if you use this outbox pattern, what happens is that on the background you have something running, and if it needs to wait a minute or 2 minutes for an infrastructure update of the queuing system, well, the events just buffer up in the outbox table, but that's not a problem because you know that you've stored them and they're stored securely. And then as soon as the destination, so to speak, for the messages is back online and back available, the relay starts flushing that buffer into that source, or into that destination. So this makes it quite reliable. So in essence, what you do is you store the aggregate and the events in a single database transaction, and this is what makes it work. So what it boils down to is that you can make these two guarantees now in this system. One is that every event is put on the queue, and you don't lose events. And there's also no premature publishing of events. As we discussed before, this could be kind of problematic, right? So some objectives that I want to have for most of the stuff that I do, I want to make it database abstraction layer agnostic. So I want to create sort of a base shape of a package that can be implemented or extended with for example, Doctrine, but also for the Laravel database. So it should be agnostic of whatever you're storing into, and it should be composable by design. So in event source, a lot of stuff is focused around composability, and that means that one interface might be implemented a number of times, and that you can even wrap certain interfaces with decorators to create more meaningful structures, and we'll probably do the same. So without further ado, let's go to phpstorm. Alright, so I've got a little setup. Is that how you say it? Setup. It sounds kind of redundant, but you know, that's fine. And what I've done is I've created a composer.json file with a phpstorm auto load for event source message outbox in the src folder. I'm depending on a dev branch of event source that makes sure that I get the latest version that we're preparing for. And I've added a PHP unit, Illumina database, and Doctrine dbal as dev dependencies. First I want to get into the sort of agnostic space of it, and then we're going to see how far we can come with creating an actual implementation of one of these things. Alright. This is also my first time live coding, so if anything fails, we'll see what happens. So in the index.php, I've set up a connection manager. So this is from the Illumina database package. I'm creating a new manager, adding a connection, and then I'm dropping if there is a Outbox messages table, and then creating a new one, which is the Outbox messages table. It's got a big int because we're going to store a whole bunch of messages, and then I've got a JSON field. Don't really need a JSON field. You could do a text or a varchar. I discussed this today with somebody at work, and for our own, we're using a varchar, like a string. I don't know how you set the length on these things, like this. You can. I think you can set this pretty high. 16. And we're gonna, as soon as we publish something, we're gonna mark something as consumed, and that's what we're gonna filter on. So by default, we don't want to have anything consumed. There's gonna be a relay to consume that. I've got two date time things at work. We also discussed this. Well, you know what? I'm actually gonna remove this. So the only thing that we have in this table is an ID, the payload that we store is a string, and a boolean to indicate whether or not this has been consumed or not. So I'm gonna quickly run this, and as you can see, this is Doctrine. I can remove that. I wanted to show this. So at the end, we do a show table so that you know what kind of tables there are. Right? All right. So the Outbox messages table has been successfully created. All right. So now we can get to the modeling. So what I want to focus on first is sort of the interface that we're gonna focus around. And this will be a repository interface, and a repository interface is needed in this regard because we're putting messages in and we're marking them consumed, and this might be implemented as some sort of like marking it consumed as a boolean, but it could also be actually deleting like the actual messages. So if you just want to make sure that they got into your queuing system and don't want to keep hold on to them forever, or want to keep them for a while, Something that you can do is use like a consumed boolean. So for me, always the important part about the repository is that it's always an interface where you focus on, I put something in, I get something out. So a repository with just one end, I put something in and then magically in some other place it reappears. I don't like that, so I want to be able to use this as a black box. I want to put stuff in and I want to get stuff out. So let's name this. So for this, we have something regarding Outbox messages, and it's an Outbox message repository. All right. I just realized now you can't really see the what's it called? The pop-up probably when I type this. So, well, you see the end result anyway. So if we're talking about the kind of model that we want to create or the interface that we want to create, there's a couple of functions that we want to have. Of course, we want to put messages in, and so we don't really care about anything in return there. So that's one thing that we want to do. We want to be able to retrieve a batch of a particular batch size, and this probably gives something that we can iterate over. So why we do this is because we don't, if the buffer is very full, then we don't want to do a sort of get all. We want to get them in batches. This is generally more performant for your database queries, so that you batch them in size. So you do multiple queries, but your throughput effectively will be higher. Otherwise, you will just be waiting a very long time and then getting something and then waiting another long time. After each batch, what we want to do is mark these as consumed. So we want to have a way to mark them as consumed. Again, we don't really care about the return type here, because we just want it to succeed, and if there's a failure, we probably will get an exception of some sort. So what I'm going to do now is I want to TDD this actually. So what I want to do is first create an in-memory Outbox message repository. If I could just type repository. Yay for spelling. Implements Outbox message repository. There we go. Alright, so what I've done is filled out the boilerplate, and now what I want to do is create a test for this. So I will create a class called this, and it extends the test case. I know there's probably some pest PHP fans in the house right now. Like, I know that Nuno would love it if I should do a stream once when I use where I use pest instead of PHP on it. For this one, I'll just quickly stick to what I know. Then what I want to do, I want to describe the behavior of a repository. And as I said before, the behavior of a repository is not really a method-oriented behavior. So if I want to test the behavior of a black box, I need to have interaction with it, that I can assert that the box itself functions in a good way. So how can I do that with a repository? Well, I can say that I can say persisted messages can be retrieved, for example. So if I have my repository and now I need a way to create messages. I want to get multiple, so create message. I want to probably do that with some value so that I can assert the uniqueness of this. So it's going to return a message, and inside this it will have a message, which is a new message with a new event, and that's going to be a dummy event. And this dummy event is something I prepared because I often need this, and all it contains is a value, and it has the standard serialization methods, and this allows me to test all my repository logic with something unique. So I'm going to use that string, and that's going to be renamed to the value, and that's going to be the message. So as I know that we're going to be serializing to the database in this stream as well, what I need to make sure is that it gets decorated with the right header, so the serialization can kick into place when it needs to. So normally you just set this up in Event Source yourself, but for now we can use this default headers decorator, and we're going to decorate the message, and that's what we're going to return. So this makes sure that whenever you get a dummy event, that you actually have an event that can be serialized and deserialized, because the headers they will tell you what kind of how do you say this? What kind of message type it is. So it uses the class name inflector to distill the class type, and it will instantiate your message that way. Right, so now we've got 1, we've got 2. Well, let's go bananas. We'll take 3. And then when I persist these messages, so message 1, message 2, message 3, I want to be able to retrieve them from the repository, and then default batch size of 6. We're gonna get something that's iterable, but we want to do array assertions on it. So always when I do database interactions, I generally prefer working with generators, and those you need to sort of massage back into an array. So that you can just use them. So now we can set up some assertions. So we want to assert the count, and we're going to expect 3 messages. All right, and we're going to assert the equality of, and then this is the expected. So this event should be the same as this event. I always need to type this. And now we have highlighting. Oh yeah. All right, last one. Alright, whenever I set up a test case, I always like to format it this way. And this is the what Marijn Huizenveld, a friend of mine, calls the AAA setup. AAA for quality, I guess. So you arrange stuff, and then you act, And then lastly, you assert. So this makes sure that you don't alternate between these kind of setup things and non-setup-y things that you know whenever, like this is what we're looking at, right? This is the stuff that does the behavior that we want to see, and this is the stuff where we know that if this passes, that we've agreed or made this interface the right way. So now if I run this, of course it's going to fail. Well, first it's going to fail because of a type error. Well, I don't like that. So you can always make sure that we return something like an array iterator of an empty array. I think that should, yeah, so that fixes the type error, but what it doesn't do is actually fix the use case, of course. All right, so now we can go and actually implement this. So first up is the persistence. We're going to use an internal array for the messages. And that is an array with messages. So whenever we persist something, okay, this is where it gets interesting. So whenever we interact with the database, sort of what we want to get is like, as we saw before, we have an incremental ID. And this incremental ID, we can, once we unserialize the message, we can add this as a header, and then something else that consumes this can recognize that header and then say, well, you know, I can mark this as consumed, right? So internally here, we want to get that header and update whatever we need to in order to satisfy this. So I'm going to do a bit of upfront design. Normally, I'm not really for that, but I'm going to emulate this behavior in this class. So we've got a private int, which is the ID counter, which is set to 0. And then for each message, I will add this. I need to get the ID, and the ID is one up from what it is now, and place this there. And then I'm going to add this header. So I'm going to say with header, and then for that I'm going to use in memory message ID, something like that. Maybe like this. All right. So this means that every message now, when it's stored, will have its own unique ID. All right, and so now when we retrieve something, what we can do is do the following. So we need some messages that we dispatch. So I think you can do array slice for the messages. Yeah. All right. And then from 0, will this work? Will this work? So what I want to get is the first couple of messages of that thing. So it might work if we do array values, because we're going to be unsetting them in the mark consumed. So we'll do it like this. And the batch batch size, and then I think we can do a yield from, can we do that? Well, I'm just gonna for each them now, and then yield the message. So these are messages. Typing, so important. Such fun to make a type. All right. Look, there we go. So what we've tested now is inserting and then retrieving a batch. So we've got this setup, and this setup is now green. Nice. So now we can go and describe the next behavior. Consumed messages can be, let's call it messages, can be marked consumed. All right. So I want to get some of the same arrangement up. So I want to get 3 messages, and then I'm again gonna persist them. I'm gonna retrieve 2, and then I'm gonna say mark them as consumed. Frank, do you even keyboard? And then I'm gonna, once again, fetch as many as I can. And now, what do I expect? Well, now I expect a count of 1. There should be 1 message left in the outbox. And it should be the same as we had here. So if we run this now, of course it will fail because we haven't implemented this behavior. And so now we're back to red, and we can start implementing this behavior. So for each of the messages that we get, we have an ID, and this ID is stored in the message header. This was a string before, so let's turn that into a constant. We're going to rename it message ID header. All right. Slav doesn't mean anything, Frank. So if this, and we're going to cast it to int because we might get 0, and we started counting from 1, so if we do IDs higher than 0, we should be fine. And so then we're gonna unset, actually, unset wouldn't work, unset would just work on this messages of the ID field. Oh, should we turn this into a one-liner? Oh, this is so dirty. Warning, undefined array key 2. Right. Of course. So the first should be the third. Hey. All right, nice. So what we have now is a in-memory Outbox message repository, and we are green. All right, now I want to see how green we are actually. So all right, we're 100% green over there. All right. So I see the chat is kind of quiet. This could be a good sign. This could be a bad sign, of course. So, if there's anything you would like to dig into, I know there's kind of a delay, but if you want something to be explained a little bit more detail, then yeah, just let me know, and I'll do whatever I can to accommodate that. For now, we've got a functioning outbox, and that is pretty cool. So, of course, when we're talking about the Outbox dispatcher, we want to have a dispatcher. So let's create one. So Outbox message dispatcher is a new class that we're creating that implements the message dispatcher interface from event source. And what it does, it takes the Outbox message repository, PHP 8, and then for all the messages it receives, it will persist them. Pretty straightforward, right? So this is part of what I like about composable things, is that they are smart, they have a purpose, and they can be adapted into many things. So here we just have, 19 lines of code, and we're adapting the message dispatcher to the message Outbox repository. So I think this is pretty cool. I do know that from well, okay, let's not get ahead of ourselves. I do know that there can be an exception, but first let's just create a test for this. All right. So, a test, test case, I test dispatched messages and up in the Outbox. So if I have a repository, I'm gonna use the one that I created before. I know it's solid because I've tested it, and I'll create a dispatcher, new Outbox dispatcher. That means the repository. What else do I need? I need another way to create messages. All right, so for now, I'm just going to copy this. Sometimes I create base classes for these kind of things, but yeah, I don't particularly like inheritance, so I tend to avoid it, and little duplication is not super bad. So again, message 1 is this, create message with 1, then 2. I think for now 2 is enough. Oh, come on, message, don't shoot the messenger. And then when I dispatch message 1 and message 2, now this is sort of the way that we assert. So again, we've got arrange, act, assert, and for the assertion, I'm going to be retrieving those things from the repository. Retrieve 10, but I'm just getting 2. Iterator to array. It keeps giving this expected parameter type of traversable, iterable provided. Well, I guess what I could do is refactor this. So I've changed the signature to traversable. Alright. Alright. And now it's good. Cool. Alright. So again, we want to assert the count. We expect 2 messages to be contained in messages. And we expect the message 1 event to be the same as messages event, and the same for number 2. So it's number 2 there. Right, little bit of typey. All right. So this means that this works, which is great. So now we have a message dispatcher. So this means now that we've got, at least from an in-memory implementation, everything we've got to go into persistence. So we can go 2 routes now. We can either go for the actual database approach, or we can keep on this trail and implement the, effectively the relay, so the thing that consumes the outbox and then republishes. I don't know, any preference, anybody? This is where I'm going to notice my delay. I'm just going to take a little bit of time, maybe do a sip of water to allow the chat to catch up. I see 1 vote for message relay. All right, I'll take it. The Outbox message relay. Typing. All right. So what we need from this Outbox message relay is a way to publish something. So let's see. So the thing that we want to interact with is one function, and that's going to publish a batch. And we're going to specify the batch size. So the batch size. And then what we're going to return is the number of things actually published. So if you remember the implementation of the in-memory one, what happens if we want to get 100, but we're only getting 15 messages? Well, you'll get 15, of course. So if your message relay is not really busy, and this has an actual database behind it, if the batch returned 0, you will just keep hammering your database in order to try to fetch more messages. This is, of course, not really nice. So you'll want to know when you ever hit that 0 a couple of times in the row and maybe back off a little. And that's what you want to do from the outside. So from the outside, you want to know how many messages you've actually been able to publish, because if it's 0, then you might want to get this back off strategy in place. So the first thing that we want is to get some messages, and we're going to get this from a repository. Well, before we do that, we first need to accept a repository, of course. So private outbox message repository, and this repository will be used. Otherwise I wouldn't include it. No shit, Sherlock. Thank you, Captain Obvious. So the repository, we're going to retrieve a batch based on the batch size. This is going to return a result in a list of messages, which we're going to add types for. Alright, and then for each of the messages, we're gonna dispatch it, and then we're gonna say repository mark consumed. Since this is a traversable, we don't know what the count is. We're gonna maintain a counter as well. So the counter initially will be 0. I don't know for what reason, but I always like to have the variables declared next to each other. And only if there's multiple ones that need like an extra hint, I will put them next to each other, but then end with a couple of ones that don't need this. So for every we've published, we're gonna increment the counter. Alright, I don't like the name of this. Number published. And at the end, that's what we're gonna return. Number published. Alright, oh, this is wrong. That's still wrong. So, of course, we also need to dispatch to something. So, for this, we're going to use one of the interfaces that event source uses or provides by the default, and that's the consumer interface, which has been renamed to message consumer in V1. This rename made sense for me. It's like if I look at all the interfaces here, you see message decorator, message dispatcher, message repository, and so the only one that did not follow this naming convention was the message consumer. So that's why I wanted to rename that. Alright, so now we've got a consumer in there as well. So what we can do is actually relay this now. So consumer handles the message. Alright, that works, I guess. So so sometimes I'm doing TDD and sometimes I'm not, and the reason why I sometimes don't is because I already have a solid understanding of what the behavior should be, and sometimes if I want to really drive the outside in behavior first, like a repository is always really outside in because you need to track it or treat it as a black box. But for some things it's more about sort of seeing the code do what it needs to, and then I switch. I'm not really dogmatic in that regard. Like I think to each their own, but for me, like I like to be able to alternate between these. So how do we test this? So what do we test? Well, we test that messages from the outbox can be relayed. What do I need for that? Well, I need a repository. I'm going to use my in-memory one again. I need my relay, which is I need a consumer as well, right? Consumer. And for these kind of things, what I like is anonymous classes actually. So a new class which implements the message consumer interface. I'm going to implement the methods and whenever we have we receive a message, just going to put it on an internal array, which we'll make public. So whenever this receives a message, then we can just assert on it. And now we've got a relay, which is, why am I typing this? Is a outbox message relay. This relay needs the repository and the consumer in order for it to function. So that's the arrangement. Come on. And then we're going to act. And this act will only be on the relay. We need to, once again, make sure that we have messages. So later I'll clean this up, but for now this is just the easiest. So I will need message. I'm just going to copy the ones from here. Oop, too much. All right. So part of this now is that the repository has these messages. So we're going to put them in already. And then we're going to say relay publish a batch size of 10. This is going to give us the amount of messages dispatched or relayed or published. All right, and then we're going to assert. So what do we expect here? Well, we expect this published count to be 3, right? And that's the published count. And what we expect, well, we expect a number of 3 to be in the consumer. And what else? We want to assert that they are published in the order that they were dispatched in the repository, right? So what we can say is assert equals message 1 event should be the same as consumer messages event. No type hint. Yes. All right. Message 2 1 and then 3. So let's see where we're at with this. Green. All right. So I'm curious. Is this a bit of the same cycle that you take in setting up things and designing an interface like this, or is it really different from what you would normally do? I'm curious. All right, let's see. What else do we need? Well, now what we can do is actually create the database variant of this. So now we're going to actually see what we, we're going to actually implement the Illuminate one. Alright, we're already an hour in. I should learn to type faster. Luminance Outbox message repository. This is going to be an Outbox message repository. Alright, so what I generally do in these kind of situations, so the behavior that we have described, is going to be the same behavior for everything that we've got here. So I said before that I generally don't like inheritance, but there's one case where I actually do like inheritance, and that is when you are creating test cases that are sort of contract tests, where you have multiple black box implementations of this. And this is a strategy that I use in different projects, mostly with repositories, but also, for example, for Fly System. So for Fly System, all the adapters are tested using pretty much the same test case with some variations there for error scenarios, but still overall they use the same thing. So that means that if they implement the same contract, and that's actually validated through tests, this means that it's actually safe to change them out for one of another. So if you have a database one that you use in production, but you use an in-memory one in your tests, if they behave the same, you can treat them as the same, and you can expect them to be the same, expect them to act the same. So it's safer that way. So for that, what I do is I turn this into a test case. I turn it into a test case and then make it an abstract class. And then for every time we do this, so creating a new repository, what we'll be doing is creating a Outbox message repository instead. And we're gonna add this method to return a Outbox message repository, which is an abstract protected function. Alright. So, why is this useful? Well, now what we can create is an extension of this, which is the in-memory Outbox message repository test, which extends the test case. What did I call it? Outbox message test. Ah, test. Oh, come on, Frank. Test case. So now this is complaining because I need to make sure that indeed here I return one of these in-memory things. So now if I run this, it's green, it's actually executing the tests from below. If you look at it from this angle, you can either say run this, and what it will do, it will actually run all of the childs. So since there's only one child right now, it will just go ahead and run that. But there's different ways to go about this. And we're gonna show that now. So the limited one we've got set up, and then we're gonna create a test case for it. And this is gonna implement the Outbox test case.
change to the stance. Alright, and stop. Alright, we need to have this. So we're gonna, why do we always type this? We're gonna say new Illuminate Outbox message repository. So what you can see now is that when you say run, it will, I see that you're probably not seeing this. Let me check. Yeah, you're not seeing this. That's too bad. So it will allow you to choose which one of the implementations you want to run. So you can say, I want to run them all, and then half of them, of course, will fail and half of them will succeed. So the Illuminate ones are failing, of course. All right. What we need now is a way to set up this database. And so what this needs is, I think it's called connection interface. Yeah, looks like it. Connection interface. That's going to be private. And what else do we need? Well, we need a table name because it's going to be one that we can reuse. String table name. We need something to serialize this. So as I said, we're going to use the serialization. And that's it, I think, yeah. All right, so let's first make sure that here we don't mess things up. So what we need to do here is create a setup method. The setup method, well, it calls the parent, of course, but then we want to have the manager new manager actually. Now I'm just going to copy this from the index.php. Alright, all of this here, and then instead of assigning it here, we want to assign it here so we can reference it, add the property, hint it correctly, and there we go. And then for every setup, what we want to do is get a fresh start. So the outbox messages can be truncated. So this makes sure that every test case that we have, we won't have any lingering messages in there. All right. So here, what do we need? So we need that connection. This has been set up in the setup method, and we need a table name. Well, that's going to be the same as above, and then we're going to use a serializer, and for this we're going to use the constructing one. This is the default one that that we ship with. So now this serializes to JSON, or it serializes to just scalar values. All right, so next up is the implementation. So if we're looking at the test now, we run the test, it's going to fail. Well, first because there's nothing to return. Cool. So, to persist something, let's see if I remember all of my Illuminate database code. I've done a bunch of these when I did some workshops for some Laravel people to learn event source. Let's see. So in the end, what I want to get into is a couple of inserts into a table, and this can be done like so, where you have the table name and then you do insert. So Laravel database allows you to do bulk inserts like this, but for that you need to make sure that you map everything to the thing that you want to insert. So for that we'll be using array map and a function which receives a message, and we're gonna format every message to have a payload. That's going to be created by the serializer. So we're going to serialize the message. We're going to create this. We're going to create JSON out of this. So now we have. Let's see. Is that it? I think that's it, right? So the default of consumed is false. So if we insert that, that's correct. We could make it explicit, but I don't really care. So the only thing that we need to do is return this, and I think if I remember correctly, the field is called payload. Payload, and that's correct. So the payload is the JSON. All right, I'm just gonna inline this. All right, and then call this payload. Then everything is nice. Well, we can even inline this. Nice. All right, so this means that we're mapping over all the messages, we're serializing them, we're JSON coding them, and then we're creating something that can be inserted into the database. Now we can go towards retrieving those. That will probably make the first test green. So for that, we want to get the connection and select something from the table that we configured above, but we want to filter by that consumed variable. So we want everything that's not yet been consumed, and we want to select that and get the results. So results is this. From what I know, the results they're, I think, standard objects. So if we want to get the payload, we need to JSON decode the results the row payload. We want to get an array back, and then we're going to create a message out of this. So we're going to say serializer, give me a message from the payload. And so similarly to how, like, there's an ID that we need to reference in order to mark this as consumed. So what we want to do is actually have a message with a header, similarly like before, where we have a illuminate outbox message ID, and then have the ID here. Well, here that's the row and then the ID column. All right. And so this is what we want to return. So this will yield, so it will be a generator. We get all of them. What else do we need? Well, we need to limit this. Limit it to the batch size. All Alright. I never like to set a limit and then not set the offset. So let's see what our tests do now. Both fail. Base is not correct. Maybe we messed up the table name. Outbox messages. That should be better. Alright, we've got the first one succeeding, and the one that says we mark it as consumed is failing. Alright, so let's implement that. So for all the messages, we want to get the IDs because that's what we're going to use. So the thing I want to work towards is for the connection table, this table name, and then use a wherein ID IDs, and then update those to be consumed, and this would be enough. So how can I do this? All right, so sometimes like you can be clever, but you can also just be, well, you don't have to be. We can map this, array map, and then we're gonna get a funky function which has a message, and we're gonna say for we want to get an int back, and then from the message we're gonna say get the header, and for that we need the same one. So now we're gonna turn this into a constant. Of course, this is still not correct, but yeah, we need to pass it the messages. Messagea, that doesn't mean anything, Frank. All right. Let me see, is this? Et voila. All right. So this means that we've created an alternate interface that allows us to use this outbox as a message dispatcher. Now we've got two implementations. They use the same base class in order to, or the base test class in order to validate the behavior. They both implement it and they both succeed. So now if I just run all of them, we get everything green. Cool. All right. Let's see. Is there anything else we can do? So, of course, we've only made sure that we're actually dispatching into something that is a database. And for that, we've got the database implementation. But what we don't actually have is the transactional boundary. So, this is where composition comes into play. So, based on where we want the transactional boundary to exist, what we can do is wrap that in something that we decorate with something that executes a transaction. So, for example, if we want to provide a way to say illuminate, if we want to provide a aggregate root repository, for example, that is transactional, so that we when we persist the aggregate root, then we open a transaction, we store the events, and then we also dispatch them in the outbox, and that is going to be wrapped in one transaction. Well, what would that look like? So illuminate outbox or transactional aggregate root repository implements the aggregate root repository. So what this thing will do is decorate a different aggregate root repository. So we're going to assign these two variables. And then when we retrieve something, we don't really care about the transaction. Repository. So we're just going to forward the call for persist, and for the other one we're going to do something else. So this connection, so we're going to do a transaction. Persist aggregate root. This is going to be quite similar, but then aggregate root ID, aggregate version, and the events, and we need to explode them. So this satisfies the interface, so that's pretty neat. So so what happens now if we want to use this? So I think there's in memory aggregate. No, I want to see aggregate root repository. There's a constructing one. Yeah. So if we're going to go towards the index.php, and then I'm going to sort of show you how this all ties together. So if we have a inner aggregate root repository, and that's a constructing aggregate root repository that needs an aggregate root class name, a message repository, which we in memory message repository, and then a dispatcher. For this we can use the Outbox message dispatcher. That needs a repository, so we can use the Illuminate one, which needs a connection, needs a table name, it needs a serializer, alright, what else do we need? I think this is it. Decorator, we don't really have to care. So now we've got something in the database here. We've got a, well, in-memory one now, but imagine this being a different kind of, well, the same kind of database transaction or connection with the same connection here. And now when we use our aggregate root repository, you can actually say new Illuminate aggregate root repository, and we're going to use the connection and this inner repository. So now if we get an aggregate from the aggregate root repository, and You normally do that with a aggregate root ID from string, something like this. And then you interact with the model. Interact with aggregates. And then you say, well, repository persists the aggregate. So what this does is make sure that we're entering in a transaction, and then we're actually gonna be persisting this. So in the constructing one, what you see is that we persist the events as we go down. And what this means is that it's going to be stored in the message storage, so in the message repository. So this is a database, and it's going to send it off to the dispatcher. So what this dispatcher does for us, is actually go towards the Outbox message dispatcher, which again uses a repository, and so the messages are persisted there, and this is where we have the second database interaction. So this makes sure that all of the interactions are encapsulated within the same database transaction, and then there's only one thing left to do, and that is to have a script running somewhere that just says while true. And this could be any background job and then we're gonna first create a publisher or relay, new Outbox relay that needs a this repository. All right. What else does it need? A consumer. So here you can do the same trick as we did before. And now we just leave it like this. So here we can say while true, for the relay we're gonna publish a batch, like we're gonna do something like hundreds, and then we're say the published amount is this, and if the published amount is 0, for example, we're gonna sleep for a second. So this means, and let's go back to the slides, if we go back here, so the aggregate root repository that we had is sort of the order service that we had here. We do a transaction effectively for us because we're event sourcing. There's two places where we store events now, and they're going to be identical. One is going to be the source of truth for reconstituting the aggregate, and the other one is going to be for communication. And it doesn't matter that we store them in two places, because all the events that we record anyway are immutable. If there is a non-event sourced model that you persist, then this would just be like the orders table, and then you get the order events table next to it. It's all wrapped, and you can either decorate your command handler or some kind of service clause for this. It really doesn't matter, but you decorate it in something that guards that you go in from one place, have all the interactions, and then go out to the other one, and then you wrap that interaction in a transaction. This makes sure that your model is updated and your events are dispatched in one go. And then you use a secondary process which uses the message relay to
fetch those messages out of the outbox, and you publish them into whatever you want to consume it in. So at Molly, what we do, we use a lot of RabbitMQ, and there's different queuing systems coming up for us, but for now that's what we use. So we've got something that publishes it into MySQL, and then on the other hand we have something that reads it from MySQL and makes sure that at least once it's guaranteed to end up in a different consumer. So in that case, a RabbitMQ topic. So I hope this sort of clarifies a couple of things. So what the pattern is, what it's useful for, and also get a sense of how you can implement it, and maybe also get a sense for how this compositional way of doing things works. So yeah, with that, I would like to thank everybody. That's basically all I had for this time. I think we got a fair amount of code generated out of the way, and yeah, let me know if you enjoyed this. I will probably do a couple of other streams like this. This was my first time doing broadcasting live coding, so yeah, if there's any pointers or tips, I'm always eager to hear feedback. If not, thank you for your time and hope to see you next time.